Okay, continuing with rational functions. Rational functions have vertical asymptotes. Vertical asymptotes of a rational function occur where the denominator equals 0. These are the excluded values of the domain. Okay. Find the vertical asymptotes of the following functions. Well, what we're going to do here is we're going to set just the denominator equal to 0. Get negative x equals negative 2 or x equals 2. That's where your vertical asymptote occurs, okay, on that function. So we expect there to be like an imaginary line that the graph cannot cross there. On the second one here, again, we're going to set the denominator, x squared plus 3x minus 10 equal to 0, and we can factor this one, this denominator, to solve. So we get x minus 2 x plus 5. Okay, so this one's actually going to have 2 vertical asymptotes at those 2 spots. Now, what's interesting is to take a look at what happens on a graph with vertical asymptotes. Y values of a graph approach either positive infinity or negative infinity when a graph gets closer to a vertical asymptote. And I really encourage you to explore this, but we're going to take a look at it graphically here with the first one, f of x equals 1 over x. Now, we need to realize that this one has a vertical asymptote at x equals 0. And you'll see that here on this graph. It's kind of hard to see on my screen, but a little better printout on your notes. Notice here at 0, it's undefined. But let's take a look as values. Here I put in 1, then I put in values that get closer to 0 from 1. Here, you'll notice as this gets closer to 0, our y values are getting closer to infinity here, and you can see that on the graph. Okay, same with the negative direction here. As I put in x values that get closer to 0, I get bigger and bigger but negative y values, and you can see that on the graph as well. This is not unique to just 1 over x. It actually happens at just about any vertical asymptote. Here on this graph, we have a vertical asymptote at negative 2, so I'll dot that in. Here, you can see that in the function, if you set the denominator equal to 0, our vertical asymptote at x equals negative 2. Now this one's a little different because of this squared here. This vertical asymptote, because of that squared, has what we call a multiplicity of 2, because of this 2 right here. Okay? And you'll notice here, in this case, what we see is as we put in values that get closer to negative 2 from the left, the graph goes to negative infinity, right? And as we put in values from the right that get closer to negative 2, it also goes to negative infinity. This happens because of this multiplicity of 2. Anytime your multiplicity is even, the graph will approach the same infinity from both sides. If it's odd, it will approach opposite infinities.